So in this video, we are going to learn how to create a linear regression model in PyTorch. So this is not a beginner's tutorial, but definitely you can follow this to understand how we create a model in PyTorch. You'll have some idea, you'll get some idea about PyTorch. So I'll not waste time and I'll start it straight away. So the first thing first, like we need to import few libraries here. So mostly from PyTorch. So the first thing is torch, then torch.nn as neural network, and then from torch as well I will be importing optimizers as optim, and to plot graph I will be using matplot, plotlib as pyplot. Okay, SPLT. Okay, these are the four things I needed. All right, so now it's time to create our data. So basically I'm going to take an example of house price versus the price, no sorry, not house price, house size versus the price. Okay, so I need to create some data x and y so that both of this will be in the linear relation, since x, if x increases, y should also increase. All right, so I will create it this way. Basically I'm going to write a random number torch.rand, and I'm going to use it one. I'm going to take 100 rows, and since this will give us a value between 0 to 1, so that's why I'm trying to convert it into some numbers between 0 to 100. And for y I will create some linear relation like 3x, not x, it should be caps, and let's say 10, and yeah, let's say 10, that's fine. And towards that I will be using normal distribution. This is noise, actually noise. I don't want our data to be very perfect. Instead, like I will add some noises. Okay, so I'm creating normal distribution. What is normal distribution? Basically the mean will be 0 and the standard deviation will be 1. So it will also be written in the same way, 100 rows and 1 columns, and I'll add 10. Okay, so that it doesn't lie between 0 to 1. Okay, now it's time to plot our graph to see how input data looks like. Okay, so the first thing is scatter x y, and then I will quickly label it x label, house, house size, plt y label, house price, and then plt title, uh, house size versus house price, and then last thing I'm just going to show it plt dot. Now, as you can see, we have some data in, I mean, the y is linearly related to x. So our, if we create some model, it should go from here to here. It should be a straight line from here, right? So if we are able to achieve a straight line going, I mean, passing through it, then our model will be close to, I mean, will have good accuracy. Okay, so without wasting time, we'll write, we'll we can, so I will be writing some model. Okay, so to create a model, what we do in PyTorch is we create a class, and we inherit it from base class nn.Module. Okay, it's giving me suggestion regression module, or just type in model. Okay, nn.Module is base class, and I'm just going to write constructor. This will be self in features out features. Okay, in features I need to call parent class, and I will be passing the type of this class and its context. Okay, and then I can call parent class init method. Okay, now what we are going to do, we are going to create a property called linear, and this will be actually y equal to w x plus b equation. So basically linear model gives us a linear equation, so it's a single node kind of thing, so you can think it I mean, you can understand it from this diagram where you see like if there's a node, I'll not call it a neuron, but understand it like there's a node and there's a one input feature and one output feature, and nn.Linear is actually giving us wx1 plus equal to, I mean wx1, and there will be one bias b equal to y. Okay, this way. Let me write it here as well so that it will be more clear. First, I am going to pass our in feature. Okay, what is happening? In feature, out features. Okay, all right. So we have created an instance of nn.Linear model. So when we inherit from nn.Module, to create a model, we need to override a method forward. So we call it, we use it for forward pass. This is actually we take help of for predicting something, and this will be executed actually at the time prediction. So I'm just going to return self.linear, this linear, and here I'm going to pass my x. Okay, and then this will be actually a forward pass prediction. Okay, here I'm not using any activation function, so it will be straightforward, a straight line, y equal to w star x plus b. Okay, so here x is x, and model will start from random w and b, and it will give us a prediction. Okay, so instead of y, we can write prediction. All right, so I'll enter. Okay, before I go further, I forgot to do one thing here. So our data is very large, zero falling between 0 to 100 for the input. So that will create a problem while learning. Okay, so what I just wanted to do is I wanted to normalize X. So to normalize, there can be various approaches. Right now, what I will do is like I will divide it by maximum value of X. Okay, it should show same diagram. Just it will reduce the value range of house size. Now it will be easier to train. Okay, we have this model. Now we'll create a model instance. So linear regression model. Alright, so this needs two parameter input and output. So if you want to understand it this way, then these two won't be here. There will be one input and one output. Okay, and now with the help of this model, what we need here is we need to create a loss function instance. So we call it criterion for nn dot mean square error loss. Okay, and we'll use this instance to get the loss data. Okay, and the last thing is like we need to initialize our optimizer. We'll discuss like why we need optimizer. For now, like I will be using stochastic gradient descent. You can study what is stochastic gradient descent. Otherwise, I will create separate video for it. So I'm going to keep the learning rate as 0.01. If I keep it 0.01, I will need too many epochs. Okay, so epochs is nothing but it's a iteration number. So instead of going for 0.001, I'll keep it 0.01. Okay, now it's time to write our loop. So I'm going to create two variables, epochs, and I'll keep it 4000. Then I will create one variable for losses, and it should be one array. Now I'm going to create a loop, epoch in range epoch, so it will create a list from 0 to 4000. And then the first thing is like prediction. How will predict? Will pass x in model, it will call the forward, and so we call it a forward pass. So the data goes from here to here. This is a forward pass. Okay, so the forward pass is done. It gives us a predicted value. Now it's time to calculate the loss. So if you don't know what the mean square error, definitely should look out. It's straightforward, like it creates the mean square of the predicted data, criterion, and y prediction, and y. Now we have the loss. The next thing what we can do here is just to keep the losses so that we can plot the graph later. I'm just going to append it. It is giving good suggestion. Probably I would have written it earlier. That's why it's very common code. Okay, so now we can write. We can reset the optimizer now, but since we have not written anything related to optimizer, the next thing what we are going to do is we are going backward. So in backward, what happens is like it calculates the gradients. Okay, with respect to w and b, it will calculate the, it will have the gradient, but it will do is like it will calculate the new weight, and that will be updated by the optimizers. Optimizer.step. So optimizer step will go back from here, and it will start updating all the weights. So right now we have one node, but it can have many nodes, and it will update all the weights and biases. Okay, so since optimizer accumulates gradients, so we need to reset the gradient every time in every iteration. Now since that's all, uh, related to the logic, but we need to print something, and printing 4000 times is not good. So what I'm gonna do, I'm gonna create percentage. Okay, 100 is fine, 0, and print f. Oh my god, where I'm typing. So epoch, thank you for giving me a suggestion, but I would like to use this way. Epoch and slash, I need total number epochs, and this, then I need loss. So loss, I will have loss dot item, but I just want to see the 4 digits after decimal. So what I'm gonna do is I'm gonna write this way, and it will show these 4 digits. Let me just try to run it and see if this works or it gives us some error. Wow, so we are getting our loss, and if you see initially it was used, and at the end of 4000 epochs it came to 77. That's good. So now the next thing is like we'll plot this, and two graphs. First we'll plot epochs versus loss graph, and then we will try to draw our prediction straight line, okay, on original graph on this one. Okay, so let's do the first thing. Let's plot the epoch versus loss graph. So for that, what we are going to do, you can directly put plt dot scatter, yeah, I think plt dot plot, that is not scatter, x and y, but here since I'm using epochs, right, so epochs, I need data, like the range epochs, and then y I need this losses, right? Since I am already having a list, so it should work. And let me define some level as well. Thank you for giving me suggestions. Then PLT y level, it will be loss, and then PLT title, it would be epochs versus loss, and then PLT dot show. That's all. Now it should show a graph with falling loss. I don't know what happened. Instead of table, label. Okay, so it should be EL. Okay, now you see, like, it initially started here, and after 4,000 epochs it ended here. So although it's not very too accurate, but still it was able to learn and create, understand. I mean, now the parameters, if you check the parameters, it will be quite accurate. What I mean by parameters is W and V. You can check it, like you can use list model dot parameters. Okay, these values, y equal to wx plus b, will be very close to the graph. I mean, uh, this graph, I mean, it should fall here, somewhere here, like the straight line. Okay, we can also plot it. So what we are going to do is, like, we are going to get the predicted value, predicted, and here what I'm going to do, model x, we are passing x value, and we are going to detach is method, and numpy, we are going to convert it numpy. And the first thing is, like, we are going to plot x and y, is giving suggestion, and but not x and y, instead like numpy, although I believe it doesn't need numpy. Instead what we can do is, like, we can keep it x and y. I just want to show level, right? So level, we can keep it actual as well, pure true data. And color, I would say blue, or how about green. Okay, now plot, plot. This is our model. Okay, so x will be the input value, and predicted will be our output, predicted output. Okay, and label will be predictions. Definitely we can try it with the test data, but right now I'm not using any test data separately. So this is set, and plt dot legend, the reason can, so in the legend is, this can see, like, which is which one, which color is what, and plt dot so. Okay, so as you see, green is true data, and this line is prediction. It is coming, I mean, it is fitting properly in between these scattered points. So as you see, our model learned a bit and is trying to be very accurate. Although it can, you can try it with the different settings, like more epochs, less linear, I mean learning rate, then probably it can give more accurate result. So that's all from this video. Thank you for watching. Have a nice day.